Fine. We are going to simplify the calculations of the product moment correlation coefficient by using a method of coding when the numbers are large. And coding is not a new name to us. Coding means that when we have large data like these ones, it's a way of reducing the large data so that it's easy to work with them. For example, when we have the value of x as 1020, and at some point we're supposed to be squaring that number, is going to be so much of work and it's going to take us quite a space. So you will be able to be advised to use coding, but even before we go on, we must be advised that coding does not affect the value of r. Addition or subtraction within coding just means shifting the axis. Dividing means changing the scale. None of the two operations will affect coding. So after coding, we are not going to decode to acquire the value of r. So the table on page 127, example 10, we have the values of x and the values of y. The values of x all the way from 1020 to 1038. The values of y from 320 to 380. And we have been advised that to use coding, p is equals to x minus 1020 divided by 1. So p is the new value that we are going to acquire after coding each and every value of x. For instance, the first p is going to be realized after we take the very first x, which is 1020, if we can call it p1, which is going to be x, which is 1020 minus 1020, everything over 1, and obviously the value of p1 is going to be 0. That's why we are having this 0 here. What about p2? p2, we take the second value of x, which is 1032 minus 1020 divided by 1, which is obviously 12. 1032 minus 1020 is 12. When you divide 12 by 1 is still 12. That's why we have the value of p2 as 12 all the way until p6 is 18. What about q's? We have been advised that for every value of y, we have a corresponding value of q. For instance, q1 is realized after taking the value of y, which is 320 minus 300 divided by 5, and this is 20 divided by 5 is 4. That is why we have the value of q1 being 4. What about q2? For better understanding, q2 is the second value of y, which is 335. 335 minus 320 divided by 5, which is now this is minus 300 rather, not 320. This is 35 divided by 5 is 7, and that is why we have the value of q2 as 7 all the way until q6, which is 16. Now, within this table, we need the sigmas, and this row is about the summation or the sum of this column. We need sigma p, we need sigma q, which is 59, we need sigma p squared, which is 737, we need sigma q squared, which is 667, and we need pq, which is the sigma of pq. Of course, to get p squared, we square every corresponding value of p. So 0 squared gives us 0, 12 squared gives us 144, all the way until 18 squared gives us 324. To get q squared, you do likewise to the q, which is now the new coded value. 4 squared gives us 16, 7 squared gives us 49, all the way until 16 squared gives us 256. Of course, to come up with this column, you have to have the product of p and the corresponding value of q. So 0 times 4 is 0, 12 times 7 is 84, all the way until 18 times 16 is 288. Now, the summation or the sigma, the total sum of all those columns, you will verify P sigma is 55, Q sigma is 59, sigma P squared is 737, 667, 634. Now, we need now to realize how do we get our value of R, because the question is find R, the product moment correlation. At the end of the day, we should be able to remember that R is given by this ultimate formula. And we need to know what is SPP. According to the previous example, SPP is given by sigma P squared minus sigma P squared over 6. The number of entries there are 6. 1, 2, 3, 4, 5, 6. And what is sigma P squared? Sigma P squared is 737, which is 737 minus sigma P, which is 55 squared over 6. And this gives us SPP. If you evaluate all these using the calculator, 737 minus 55 squared over 6 is going to give us 232.83. We also need SQQ. What is SQQ? SQQ is sigma Q squared minus sigma Q squared over 6, which is actually 667, because this is the sigma Q squared, 667 minus sigma Q, which is 59, which is 59 squared over 6, and SQQ, after we evaluate all that using the calculator, should give you 86.83. That is quite critical. Then we need SPQ, which is sigma. SPQ is supposed to be sigma PQ minus sigma P, sigma Q, everything over 6. How does this work? Now, what is sigma PQ? Sigma PQ is 634 minus sigma P, which is 55 times 59 all over 6, which is going to give us 93.17. We have now collected our details, or rather what we need to calculate all this. We have SPP, which is that. We have SQQ, which is that. And we have SPQ, which is that. Substituting that, now we can do away with this table. We no longer need it. We have the values we needed. All we need to do is now to substitute all these values in the formula for R. And what do we have? What is SPQ? That is going to be 93.17. R is going to be 93.17, everything over the root of SPP, which is 232.83 times SQQ, 86.83. With that arrangement, after you use your calculator, you will get your final value of R as 0.655. And that is the product moment correlation coefficient for the two variables X and Y. But of the most importance, I want you to note that were we to work with the original values of X and original values of Y, which were quite large numbers, it would have given us a bit of a problem when it comes to squaring and addition of big numbers. But after coding, then we have had small values, and they are very flexible to work with. So you can already see that X and Y are positively correlated, meaning that the increase of X leads to increase of Y, though not very strongly. Okay?